Greetings everyone, I'm Chintan Maniar from the University of Georgia, and today I'll be presenting my work on AI-based forecasting of harmful algal blooms using satellite images and social media data. A brief introduction to cyanohabs. They are basically cyanobacterial harmful algal blooms, which look just like any other blue-green algae, but they are poisonous. That's how they differ from the similar-looking green algae. They need warm and nutrient-rich waters to bloom and then multiply very quickly. They can form colonies very quickly, and they can form a thick layer of algae on the surface of the water. Like I said before, they are very toxic. They can poison an entire water body, which can in turn kill the aquaculture, coral reef, fishes, cattle, and it can affect even us humans if we drink that water or eat something. It can give us dementia, kidney, liver diseases. It has hepatotoxin and neurotoxins, and it has also been linked to human death. So how can we do remote sensing of cyanohabs? It is important to differentiate between toxic habs and non-toxic algae. Cyanohabs have a pigment called phycocyanin, which absorbs very strongly at 620 nanometers, which is a band 7 in Sentinel-3 satellite. So we use this satellite sensor to detect and quantify cyanohabs. There are many causes to cyanohabs. They, of course, have a seasonal phenology, but of late, we are seeing a lot of non-seasonal cyanohab events due to human interaction with water body or improper waste dumping or improper wastewater management and discard policies. And social media contains a ton of data regarding all of these events, especially about cyanohabs. If somebody tweets about cyanohabs, like we can see here, if we can just flag this tweet using keyword analysis, we know that it's geocoded. It has its location. So we go to that location, we download satellite image for that location for that time, and we can see what's happening by using existing cyanohab models that are developed for satellite. But we have enough studies which detect and quantify cyanohabs. At this point, we need an early warning system which can tell us in advance, which can warn us in advance if there is going to be a cyanohab so that we can prevent the public health hazard that it causes. For that, we propose selecting a water body and then selecting the appropriate satellite sensor, in this case Sentinel-3, and extracting historical time series data of cyanohab for that water body. Now, we use 3 sets of covariables. One is the historical time series of cyanohab. 2 are the biophysical covariables that drive cyanohabs, such as water temperature, water chlorophyll content, water nitrogen content, water suspended sediment content. And we also use data from social media data. How does this help us? If there has been a policy which endorses very, very strict discarding of wastewater, then people will talk about it on Twitter and they will have positive sentiments. So using open social media data, we can capture the human factor of the whole sphere. Then we train a deep learning model which can predict in future cyanohab events. To demonstrate a use case of our study, we go to Lake Okeechobee in Florida, where the elections were delayed back in 2018 due to severe HAB events. Here we use existing satellite-based models to detect and quantify HABs, and we can see their spatiotemporal evolution. And when we look at the time series, we can see definite bumps in 2018 in both cyanobacteria and chlorophyll A. Our model allows us to forecast blooms. What we did for Okeechobee was that we extracted the time series of cyanohab from October 2016 to April 2019. We trained our model on this and the 2 other sets of covariables, and our model was able to forecast future bloom occurrences, which is actually very, very close to the actual bloom occurrence that followed. Such an early warning system is the need of the hour. Cyanohabs are becoming increasingly frequent and very, very dangerous. In Botswana, more than 300 elephants died, presumably due to cyanobacteria. CDC recently released a study analyzing the hospital visits and the HAB blooms, and the spike in hospital visits corresponds very strongly with the red tide events in the Gulf of Mexico. Recently, UNESCO also released a lot of guidelines on how to study HABs with the climate change effects. Basically, to tackle cyanohabs and to avoid future public health hazards, we need to be more aware about the cyanohabs, and we need to employ more such infrastructures so that we can make healthier water quality decisions and safer water quality policies in practice. Thank you so much. Please feel free to reach out to me in case you have any questions.